In this section, you will identify congruent figures. If you look at the first two set of triangles on the right and you look at the corresponding parts that are congruent, like this and this, these two angles are congruent. If you were to put these figures on top of each other so that the congruent angles are on top of each other, you would only see one triangle to the naked eye. But in effect, there are two congruent triangles. In two congruent figures, corresponding parts, meaning the corresponding angles and sides, are congruent. So let's take a look at these two triangles. In triangle XYZ and triangle RST, angle SX is congruent to angle R. Angle Y is congruent to angle S, and angle Z is congruent to angle T. Let's just change this color here. Okay, and corresponding sides, XY, segment XY, which is the one with the three congruent marks, is congruent to segment RS, so on and so forth. Third angles theorem. If two angles of one triangle are congruent to two angles of another, then the third angles are congruent. So let's make up some numbers here. Let's say this angle is 20, then this is also 20 degrees, and this is 46 degrees. This will also be 46 degrees. Now you know that the sum of the three angles of a triangle is 180. So if you worked out the third angles, then this angle here that I mark X will be congruent to the angle Y. So we're not saying that the triangles are congruent. We are saying if two angles of one triangle are congruent to two angles of another, then the third angles are also congruent. And we would say X, lowercase x, is congruent to Y. Properties of congruent triangles. So reflexive property says for any triangle, triangle XYZ, triangle XYZ is congruent to triangle XYZ. Remember, reflection is when you have a mirror, you see the same thing on both sides of the congruent sign. Symmetric property will now have two triangles involved, triangles XYZ and RST. If triangle XYZ is congruent to triangle RST, then triangle RST is congruent to XYZ. In the symmetric property, you just switch the position around the congruency sign. Transitive property will involve three triangles, and here you see that if triangle XYZ is congruent to RST and RST is congruent to ABC, then we can say XYZ and ABC are congruent. Okay, let's look at these problems here. Okay, this problem here says write a congruence statement if the following two figures can be proven congruent. So let's write that down. Okay, it is sometimes useful to take the two figures apart, and you can do that on your own. But let's just see. In triangle LMN and triangle PQR, we can say angle L is congruent to angle R, and then we have angle M is congruent to angle Q. So we really need to prove angle QPN and MNP to be congruent. If you look at this little triangle here, this is an isosceles triangle. And in an isosceles triangle, you can show that the angles opposite congruent sides are congruent. So if I were to sort of quickly sketch LMN here, then I would have this angle N from here. Now this is a very rough sketch, and this angle P from here. So those two triangles, they have congruent angles, and do they have congruent sides? Yes, they do. These are corresponding sides that are congruent. If you look at MN and QP using the segment addition postulate, you could show those are congruent. And you could also show using the segment addition postulate that LN is congruent to PR. So therefore we can say, and if I want to write my congruency statement, all I do is I line up the congruent angles L, M, N, and in the other triangle L is congruent to R, M is congruent to Q, and N is congruent to P. So say, and we write the congruency sign. So that's a congruency statement. So given some congruency information, we can use it to solve for triangles. If you look at this figure, on first sight you see that there is one right angle, but that means this is also a right angle. So in the triangle on the right, if this is 50 degrees, the other angle is 40 degrees. We know that this angle and this angle are congruent because they're shown to be congruent. So I can write 17x minus y is equal to 50. And also using the third angles theorem, I know that this angle here is congruent to this angle here. Okay, so I have 12x plus 4y is equal to 40. You may or may not remember how to solve systems of equations. You can use elimination or substitution. What I'm going to do is I can multiply this by 4, and that gives me 68x minus 4y is equal to 200, and I have 12x plus 4y is equal to 40. If I add these two equations, I'll get 80x is equal to 240. So x is equal to 3. So I can go ahead and put x back in this equation, and I get 12 times 3 plus 4y is equal to 40. So I get 36 plus 4y equals 40. And if I subtract 36 and subtract 36, I get 4y is equal to 4, and y is equal to 1. and you can go ahead and substitute that back in and check your answers.